Have you ever wondered what makes gold and not silver? Or why oxygen keeps us alive but carbon dioxide can suffocate us? The answer lies in something very small but very powerful, the atomic number. Atomic number, represented by the letter Z, tells us how many protons are in the nucleus of an atom. That's it, one number that defines the entire identity of an element. Hydrogen has just one proton, so its atomic number is 1. Helium has 2. Carbon has 6. It's like a name tag. No matter where you go in the universe, if an atom has 6 protons, it's carbon. Here's a bonus, in a neutral atom, the number of electrons is the same as the number of protons. So by knowing Z, you know how many negative charges orbit the nucleus too. And guess what? This atomic number also tells us where to place the element in the periodic table. It's the basis of the entire table's design. So next time you see oxygen with atomic number 8, remember, it's not just a label, it's its atomic fingerprint. If atomic number gives an atom its identity, then mass number gives it its weight. Mass number, symbolized by A, is the total number of protons and neutrons in an atom's nucleus. These two particles, together called nucleons, make up nearly all the mass of an atom. Let's take an example, nitrogen. It has 7 protons and 7 neutrons. So its mass number A is 7 plus 7, which is 14. Here's the simple formula you can remember. Mass number A equals number of protons plus number of neutrons. Protons and neutrons are heavy compared to electrons. Electrons are so light, their mass is almost negligible in atomic weight. So when we say carbon has a mass number of 12, we are really saying it has 6 protons and 6 neutrons. And here's the amazing part, the same element can exist in versions with different mass numbers called isotopes. We'll talk about that later, but it all starts with this mass number. Alright, now that we've understood atomic number and mass number, how do scientists write all of this down? They use a symbolic notation, a compact but powerful format. Here's how it works. We write the symbol of the element and to its left we place two numbers. At the top left we write the mass number. That's the total protons plus neutrons. At the bottom left we write the atomic number. That's just the number of protons. Let's write nitrogen as an example. We write 14 over 7 followed by the letter N, nitrogen. This tells us that nitrogen has 7 protons. And because 14 minus 7 equals 7, it also has 7 neutrons. It's a powerful code that chemists and physicists use every day, in nuclear chemistry, in particle physics, and even in medicine. Let's take a moment to bring it all together. The atomic number Z is the count of protons. It's what makes an element itself. If Z is 1, it's hydrogen. If Z is 12, it's magnesium. There's no switching this. The mass number A is the total number of protons and neutrons. It's what makes the atom heavy. We've also seen how to write this information as atomic notation, with A above and Z below the element symbol. This basic understanding is your entry into the world of atomic structure, isotopes, radioactive decay, and more. These two numbers, Z and A, are not just labels, they're keys to the atom's identity and behavior. I hope this session helped you see how the tiniest particles define the biggest properties and how chemistry builds the bridge between numbers and nature. Stay curious, and I'll see you in the next session where the atom's story continues.